What is a resistor? In terms of energy, a resistor transforms electrical energy into thermal energy. Some examples of this would be a stovetop element. You run current through it when you turn it on, and it gets hot, might even start glowing red. That's because it's turning electrical energy into thermal energy. Same with the toaster, same with an oven. Turns out most everything is a resistor and will do this to some extent. There is an exception. There's a class of materials called superconductors. I talk about that in a later video. They don't have any resistance. But aside from them, everything is a resistor, including you, which is why when people get electrocuted, they burn, because they are turning electrical potential energy into thermal energy. And resistors do this by way of a certain property they have, which is known as resistance. And we represent resistance with a letter R, capital R. And much like capacitance, resistance depends on the resistor itself. It depends on the physical properties of the resistors. Now, let me say there are two different types of resistors. There are temperature-dependent resistors and temperature-independent resistors. Right now, I'm going to talk about temperature-independent resistors. I have a separate video where I talk about temperature-dependent resistors. For temperature-independent resistors, the formula for resistance is rho times L over A. Rho is the resistivity. This depends on the material. So it's generally just something you look up in a table. L is the length of the resistor. And A is the cross-sectional area. So usually we're talking, for example, if you're talking about a wire, this cross-sectional area, that would just be the gauge of the wire. Now, gauge and cross-sectional area aren't exactly the same, but if two wires have the same gauge, then they have the same cross-sectional area. So again, resistivity, length, and the cross-sectional area. And so you can see what I'm saying where I said the resistance depends on the physical attributes. It depends on the composition and essentially the geometry of the resistor. And what you need to take away from this is that if those things don't change, so if you are not physically changing the resistor, then the resistance remains constant. And in general, if we're talking about a specific resistor, then its resistance will remain constant. And in fact, in all the problems that we do, except for the temperature-dependent ones, aside from those, we will always treat the resistance of a given resistor as being a constant.